Hello everyone, my name is Nazarence and I'm from the Faculty of Manufacturing Engineering. Today I'll be presenting you my title Determination of Sustainability Measures for Aerospace Manufacturing Industry. I am under the supervision of TS Dr. Amin, while my panels are Dr. Isa, Professor Hurai, and Dr. Mohamed. First and foremost, let's get started with my research background. So, recently, sustainability in aerospace has received an increasing amount of attention. So, local aerospace governments such as NICO, MITI, Matric, SME Corp, and MIDA see sustainable manufacturing as a critical step. Many aerospace manufacturers are adopting new strategies and measures to address the non-renewable energy shortage during this current pandemic. Since Sustainability Index is a comparable and quantitative scoring system, it is required to give a helping tool to assess sustainability across processes and enterprise. Generally, Sustainability Index are instruments used to measure the responsibility of a certain company in social and environmental areas. The purpose of developing an index is to improve the ability to make decisions about process changes. So this is the scope of my studies. So one of the scope is to research on integrating multiple well-known indicators into an index value in order to measure sustainability in aerospace manufacturing industry. So due to sustainability is a dynamic and comprehensive process, a sustainability index is considered to be a function of energy efficiency, waste management, and worker safety and health. By identifying each of these variables into accounts and generate a numerical index value that can be compared across aero manufacturing industry. The study will also be limited to solid waste management as control for initial data. The results will determine which company will have a better sustainability index. As you can see in the flowchart, this is the framework of my research. So what is the significance of this study? Well, in terms of cost, from the full utilization of index-based grading system, future projects will be economical. From the environment standpoint, the outcome of this study may determine the carbon footprint reduction potential. For engineers, different variables of sustainability index can be compared between industry as a benchmark measure. As for advancement of knowledge, this study may be used as future reference to determine the possible extent of prospects in the sting of aeros manufacturing industry. This is some of the literature review that has been used in this research. Now let's proceed to the methodology. The following are the step-by-step analysis conducted into developing the sustainability index. We first start with variable identification. Then after we determine what variables we want to use, we do data collection. From data collection, we do data visualization. So for data visualization, we visualize which indicator is selected as the input parameter. Also, we proceed with questionnaire development, which contains all indicator, subgroups, and factor for users' input. Next step is data entry, which will consist of users' response from questionnaire via Google form. Moving on to step 6 is model development, which will integrate users' response for sustainability index formula development. This will usually involve the performance index QI. After the model development, we do the model evaluation to see if it has reached our objective. First, we start off with one of the indicators, which is the energy efficiency for sustainability index. There are 3 indicators used for this research, which are energy efficiency, waste management, and worker safety and health. The following is the approach to measure the energy efficiency for the sustainability index. So first we calculate the performance indicator using the following formula. So as a sample, we are using the data response extracted from the compressed air section from the questionnaire. So as you can see, for this performance indicator, positive response are rated from 4 to 5, while negative response are rated from 1 to 2. Any response that is rated 3 are neutral response and is neglected from the calculation. The model is based on the consumption percentage from each user, where weighted average is used to develop a 100% ratio. The following formula is used to determine each subgroup's usage, which eventually serves as relative weightage for energy efficiency. After calculating the performance index and weightage, the energy efficiency index is calculated by multiplying relative weightage MI by performance indicator, which is QI. So as you can see from the calculation, so from the above equation, carbon footprint reduction potential can also be achieved by using energy in a more sustainable manner. Next we proceed to the waste management indicator. So the following is the formula to calculate the total waste management. We first start off by calculating the aggregated recycling percentage. After we get the G value, we substitute it into the waste management index formula to get the overall value for the waste management index indicator, to get the value of the waste management index. Once we got that value, we proceed to calculate the carbon footprint reduction potential for the waste management indicator. It is worth noted that the value of Yj is with respect to the different type of waste. Now let us proceed to the results and analysis of this research. As you can see here, this is the results from the development and distribution of questionnaire via Google form from the respondents. Respondents took part in a survey and were given the opportunity to explore all the model's potential. The detail of the feedback from respective company personnel are provided in the following table. According to the response, the aerospace manufacturing company focuses a lot on worker safety and health, energy efficiencies, and work management. So from that data, we are able to obtain the overall sustainability index for aero manufacturing. So as you can see, the following is the overall sustainability index formula. SI is the sustainable manufacturing index, while AI is the individual index on each indicator, which has value from 0 to 100. CI is the weightage on each factor. A1, A2 and A3 are the three indicators for the sustainability index. So as you can see, this is the simple calculations made, and the overall sustainability index for the company, the overall sustainability index is 50. The following is the summary of the 31 recorded responses from the Google form. As you can see, there is a total of 9 subgroups, which has its own number of questions. So by applying the performance index formula with the given data, we can get the results of of the performance index of the performance indicators for each subgroup. For the conclusion, so establishing realistic sustainability index via which manufacturing industries may compare among themselves and monitor internal development is necessary to obtain sustainable manufacturing. The obtained data and graph are informative and accurately portray realistic scenario, individual factor indices and the overall sustainability index demonstrate the sensitivity to changes. For the recommendation to make the model more robust, uh, it is recommended to insert more questions and variables. However, the number of questions must be limited so that the survey does not take too long to complete. Usually a standard strategy may be prepared after gathering and maintaining a database. This standard method will aid in determining the quantitative range of the sustainability index. Also, prior selection is crucial in the current approach. This is to prevent bias selection, as a mechanism must be established. That is all for my presentation. Thank you.